Welcome to another one of the GPI informational videos. Today we're going to talk about the difference between turbine meters and positive displacement oval gear meters. We'll start with turbine meters. This is a typical turbine meter. It's actually one of our TM series, the PVC ones, an economy meter. And they're pretty simple. Just like most turbine meters, you have your pipe part and then your display part. Now the display creates a magnetic field, which you can see with the magnet's right about there. And that magnet creates a magnetic field, so as the turbine spins, which when fluid goes through the pipe, it spins that turbine. You can see right about there, it's a little metal hunk in the end of the turbine. So each time that metal hunk breaks the magnetic field, it creates a pulse, and then of course the display counts it. And the display has already been programmed by a calibrator to know exactly how many pulses equals a gallon. And that's really about it with a turbine meter. The problem with the turbine meter is, you put water through it, that turbine spins like crazy and works just great, but then all of a sudden you put oil through it, something that's a lot thicker, and then that oil is going to make the turbine spin a lot slower even though you're putting the same amount of fluid through it. So how do you work with something like that? Well, that's where a positive displacement meter comes into play. Here's a nice positive displacement meter. It's a 1-inch. And this one's just going to be a pulse out as it is. Now the nice thing about a positive displacement meter is exactly what it says. It's positive displacement. If you look inside, you've got two oval gears. That's why we call them oval gear positive displacement meters. Sometimes you call them just one or the other term, but either way it means the same thing. And you see this little chamber here. That is where the fluid goes through. So if you have your fluid coming in this way, it's going to come in through here. And you get a little chamber of the fluid right there, and that chamber never changes size, so it doesn't matter if it's thick like oil or thin like water, that chamber always holds the exact same amount of fluid. So it goes through and pushes out and out. Same time, this side, another one's going. So it just keeps going, and so really the fluid's going this way. It looks like the rotors are spinning backwards, but it pushes the fluid right on through and counts it. Now it works the same way a lot, or the same way. You've got on your rotors, you've got magnets. Instead of the magnet being inside the display like here, you've got the magnets in the rotor. It actually goes through the bottom side here, and so the magnet's on this side. So when you have that in there, the magnet is sensed by a Hall effect or a reed switch. Here we got the reed switch. As you can see underneath, you've got actually two reeds. Now let's see if we can get right. Two reeds. One here is like a little glass tube, and inside that glass tube is a real thin wire, and that thin wire will bend down every time the rotor goes underneath it, and the magnet draws it down, and it'll touch a stiff hard wire, and that gives it continuity. And then once the magnet's gone, the reed or the thin wire straightens back out. And every time you get continuity, and then back to no continuity, that gives you one pulse. Now we also have a Hall effect, and here's an example of a Hall effect, and you can just see there's two little things sticking up off there because this one has two Hall effects on it. And a Hall effect is basically the same thing except for it being mechanical, where you have that moving wire. It electronically senses the magnets going by. So if you've got power available, a Hall effect is a great way to go because you have no moving parts. But if you don't have power available, and you're just running off a battery that's inside the display, a reed switch is a great way to go because then you can have it work just about anywhere. And that's the main difference between a oval gear meter and a turbine meter. Now our oval gear meters, like I said, here you're showing one that's just going to be a pulse out only, to where it's just got like this, wires go straight into that reed switch I was talking about. But you can also get it with a display. So it's going to look like just like that. The display can sit on top, just a regular GPI display on there. And it's going to do the same thing. It's going to count those pulses. The display, it knows exactly how many pulses equals a gallon, just the exact same way the turbine meter does. And so then you can see what you've got on there. Also, you can send out 4 to 20 milliamp signals or pulses. Here's one that has a 4 to 20 milliamp signal. Got your 4 set and 20 buttons to get that working. And the only other thing notice different about this meter is the size. You've got the display, but the oval gear meter is real tiny. You got your normal size here. This happens to be a 1-inch. This is a little 1/4-inch one. You can see little 1/4-inch inlet and outlet. And so it actually has the meter here, and then the display mounts on top. But still, it works the exact same way. It's just got little tiny gears inside it, like this one has. These are just larger. And it still, through this cable, sends the pulse over to the display. Now, there's one other oval gear meter we've got. It's a mechanical one. Got this one here. Works basically the same way. You've got mechanical. So there's no electricity, no batteries, no nothing there. It's just wheels turning, and the wheels, of course, they're connected to the rotor again, except there's a shaft that comes up through the center. As this spins, the shaft spins, which then actually would turn the numbers. And the nice thing here, you have this out in the middle of a field or someplace where you're trying to meter some fuel or something, and you don't get there for once or twice a year, or at least a few months. It's no fun to get out there and find that your batteries have died and you've lost all your information. So a mechanical meter works real well in that aspect. That's really about all on the difference between the turbine meters. We've got several different turbine meter types. We've got several different oval gear meter types on this side. And if you have any questions about those, don't hesitate to give us a call. We're glad to answer any questions you have. Thanks a lot.